Hello, my name is Eric, and today I'm going to teach you about waves at work. Today's lesson is based on Unit 4.2 in your book, page 52 and 53. But again, if you do not have your book, don't worry, all of the information will be displayed in this video clip. And before we start with the book, let's have a look at this image. What's happening here? Now I want you to think of some questions you could ask to find out more information about this situation. It could be about what's happening right now, what's happened in the past, or what might happen in the future. So what questions could you ask, beginning with who? What? Where? When? And why? But our goals for today's lesson are to know what work the waves do, to understand the processes that erode the coast, to understand how material is transported along the coast, to understand why beaches form in some places and not in others. So let's start page 52, the waves at work. What do the waves do? Well, waves work non-stop, night and day, year after year, shaping the coastline. And this shows us what they do. So number one, they wear away or erode the coast. The cliffs are being eroded. That means some of the rock has already been weathered, broken down by weather and plants, and now the waves are eating away at the coastline. Number two, they carry away or transport the eroded material. And number three, they drop or deposit it in sheltered areas where they lose energy. So the three main jobs the waves do are erosion, transport, and deposition. This may seem familiar to you because last year you studied about rivers, and these are the exact same processes. So before we continue, we're going to watch a short video called How Do Waves Shape the Coastline?
How do waves shape the coastline? The UK has a lot of coastline, almost 18,000 kilometres of it. That's about the same as the distance from Scotland to Australia. Our coasts are constantly under attack. In some places, the coastline is being torn apart by waves and huge chunks of land are being lost to the sea. In other places, waves are building up beaches with sand and shingle. So, how do waves do this? They wear away our coastline through a process called erosion. The amount of erosion depends on the type of rock that forms the coastline and the energy of the waves. Waves erode our coasts in 4 different ways. Hydraulic action happens when waves crash against the coast with huge amounts of energy. This forces air and water into cracks in the rocks, weakening them and eventually breaking them up. It's a bit like using a power hose to wash dirt from a car. Solution is another type of erosion. It happens when certain chemicals in the rock are dissolved by weak acids in the seawater. There are 2 other types of erosion. Abrasion happens when sand and pebbles in the waves are flung onto the coastal rock, wearing it away like sandpaper. And finally, attrition happens when the bits of rock that have broken off the coast collide into each other. Over time, these rocks become smaller and smaller until they end up as shingle or sand. So, what happens to the material that gets eroded from the land? Waves transport it from place to place. They can carry sand and shingle up and down a beach or out to sea. Sometimes waves transport material along a beach from one end to another in a process called longshore drift. It happens when waves approach the coast at an angle, taking sand and shingle up the beach with them. Gravity then pulls the water straight back down the beach, so the sand and shingle get moved further and further along. If waves are gentle, they may not have enough energy to transport material back down the beach. Instead, they deposit it, building up our beaches. The processes of erosion, transportation and deposition are always at work around the coastline, shaping and forming some amazing landforms. So, next time you're at the beach, see if you can work out how the waves are shaping the coastline.
So now we'll look at each of these processes in more detail, starting with erosion. So this is how waves wear away the coast. So first, they pound at the rock like a hammer. So over time, the force of the waves break up the rock. They force water into cracks in the rock. That helps to break it up. This is called hydraulic action. They dissolve soluble material in the rock. This is called solution. They fling or throw sand and pebbles against the rock. These wear it away like sandpaper. It's called abrasion. So abrasion is basically little pieces of sand or stones in the water that rub away at the rock on the coastline. They scratch away the coastline. Then, the bits of rock that break off also get worn down by knocking against each other. This is called attrition. So by this process, the rocks keep hitting and rubbing off each other, and they get smaller and smaller. They end up as shingle and sand. Shingle is a word for a big mass of pebbles. Not all beaches are sandy. Some, like this one, are made of shingle, or lots of little pebbles, lots of little stones. The more energy the waves have, and the softer the rock, the faster the erosion will be. Now let's look at transport. The waves carry the eroded material away. Some is carried right out to sea, but a lot is carried along the coastline like this. Number 1, this pebble is carried off the beach. 2, by backwash and gravity. So remember, backwash means the water returning to the sea after the wave has broken. So this carries the pebble back out to sea. Now we see the purple arrow showing the direction of the waves. So the waves are moving slightly east, so that carries the pebble along the coast to number 3, then onto the beach again by the uprush of the next wave. Number 4, the backwash carries it off the beach again, and number 5, the uprush carries it back onto the beach. And number 6, so on. So it keeps moving on up the beach by the process of backwash and uprush and the moving waves. Now the direction of the waves are caused by the direction of the wind. Hundreds of thousands of tons of pebbles and sand get moved along our coastline every year in this way. And we call this process longshore drift, because the material is drifting or moving along the shore. Many seaside towns build groins. These are made of wood or concrete, and they're built to stop beaches being carried away by longshore drift. So in this photograph, these are the groins here, and they're built across the beach out to sea, and they stop the sand moving up the beach. They catch the sand, and they stop it being carried away by longshore drift. And finally, deposition. Waves continually carry material on and off the land. If they carry more on than off, then a beach forms. So if the uprush is stronger than the backwash, then beaches will build up. Beaches form in sheltered areas. So when an area is sheltered, there's less wind, so the waves have less energy, and these low flat waves carry material up the beach and they leave it there. Some beaches are made of sand and some are made of shingle, as I showed you on the previous page. Now it's your turn. X and Y are two pebbles or stones made of the same rock. Which one has been in the water longer? Explain. And name the process that made Y so smooth. So pause the video for 2 minutes, or for as long as you need, and write down your answer. Finished? Okay, let's check. So your answer should have the same details, but you might use different phrases. So which one has been in the water longer? Y has been in the water longer. Its rough edges have been worn down over time. So Y is smooth because over time it has lost those rough edges we see in X. So B, what is the process that made Y so smooth? Y has been smoothened by attrition. So as the rocks and stones in the water hit against each other, they get worn down and they lose those rough edges. Next, look at this photo again. Groins are barriers of wood or concrete built on a beach. Why were these groins built? Are they working? And how can you tell? And in which direction is the longshore drift moving? Northeast or southwest? Give evidence. We can see the north arrow on the map or on the photograph here. So use that to answer your question. So again, pause the video, and when you're ready, we will check your answers. Okay, have you finished? Let's check. So first question, why were the groins built? The groins were built to stop the sand being carried away by longshore drift. Question B, are they working and how can you tell? Well, if you look carefully at the picture, we can see yes, they are working. There's plenty of sand still on the beach. So the purpose of the groin is to stop the sand being taken away by longshore drift. And we can see it's working. The sand has not been taken away. Question C, in which direction is the longshore drift moving? Northeast or southwest? The answer is, the longshore drift is moving northeast. We can see the sand building up on the southwest side of the groins. So the longshore drift is moving northeast, this direction, and as it moves, when it hits the groins, it deposits the sand on the southwest side of each groin. Now have a look at this drawing. it shows part of an island. In the picture, the prevailing wind, or the usual wind direction, is blowing. So from where does it blow? What is the direction of this wind? There is no beach at A on the picture. Here. Why? There is a beach here at B. Why? And D, where might the sand at B have come from? So again, pause the video, and when you have your answers, we will check. Okay, let's check your answers. Question A, the prevailing wind is blowing. Where does it blow from? The wind is blowing from the southeast. We can see the waves are hitting the cliffs on the southeast of the island. So the waves are moving in this direction. That means the wind is blowing in that direction too. We can see the waves along the sea like this. So they are moving in this direction from the southeast. Question B. There is no beach at A. Why? Well, A receives the full force of the waves. There's a lot of energy in the water, which causes erosion, not deposition. So A is facing the wind and it's getting the full force of those waves. Big, high, strong waves have a lot of energy and they erode material. So we have no deposition here. Question C. There is a beach at B. Why? Well, the bay at B is sheltered. This headland sticks out and it shelters B. The water here has less energy, so it deposits sand and shingle, building up the beach. And finally, D. Where might the sand at B have come from? Well, the sand at B may have come from the material eroded at A and transported by longshore drift up the coast and deposited in the bay at B. So that's the end of the lesson. Let's review the main points. The three ways in which the waves shape the coastline are through erosion, transport, and deposition. The processes of erosion are hydraulic action. The force of the water blasts material from the rocks and cliffs along the coast. Abrasion. Sand and stones in the water hit and scratch the coast, wearing it away. Attrition. Rocks and stones in the water get broken and worn down by hitting against each other. Solution. Minerals from rock are dissolved in the sea. So they are the processes of erosion. Longshore drift is a process of transport. It moves material along the coastline in the same direction the waves are moving. And the direction of the waves is determined by the direction of the wind. When waves have more energy, they erode more. And when waves have less energy, they deposit more material, building up a beach. Some other vocabulary from today. Shingle, a mass of small stones or pebbles, especially along a seashore. And groins, barriers built at 90-degree angles to the beach, reaching out into the sea. They block longshore drift and prevent sand from being transported away. So that is the end of today's lesson. Thank you for your attention and have a good day. Goodbye.